Alright, so this is on section 5.4, which is on confidence intervals for the difference between two means. So let's first start by recalling, according to the central limit theorem, that the sample mean has a normal distribution where the mean is the population mean and the variance is the population variance divided by the sample size. For the central limit theorem to work, we need the sample size to be greater than 30. Now, if we have another set of sample, it follows the same pattern. And we also need the sample size to be greater than 30. If we want to investigate the difference of these two samples, then we know if we take the difference of two normal distributions, the new mean is just the difference of the two original means, but the variance is actually the sum of the two original variances, and this is very important. Now, if we have this, then we can construct our confidence interval we want. So we can construct the confidence interval for the difference of the population means. So the mean part is given by x bar minus y bar, and we have the plus minus the magical z number, z sub alpha over 2, with the giant square root. Inside the square root is our variance. And here, we know that we often don't know the values of the population standard deviation. In that case, then we use the sample standard deviations instead. Okay, so now we have this formula for confidence intervals. Let's use it on an example. So let's sample 100 men and 200 women and measure their heights. So let's say among these 100 men, the heights has sample mean 178 centimeters, and the sample standard deviation is 7.5 centimeters. And among the 200 women, their heights has sample mean 165 centimeters, and the sample standard deviation 7 centimeters. And we can use these data to construct a 95% confidence interval for the difference between men's average height and women's average height. Okay, so let's first identify the things we need. So this is sample size for x, this is sample size for y, and this is our x bar, this is our y bar, and this is our sample standard deviation for x, and this is our sample standard deviation for y. So now we have everything we need. We can construct our confidence interval. So the x bar minus y bar will be 178 minus 165. And because it's 95%, so we know this number is going to be 1.96 always, times square root of 7.5 squared divided by 100 plus 7 squared divided by 200. And we're going to use calculators for this part. So this turns out to be 13 plus minus 1.761. Let's not forget the units. These are centimeters. So this means that we are 95% confident that the difference between men's average height and women's average height is within this interval. All right, so that's it for this section. Thank you so much.